Welcome back, MECH1320 Mechanical Components. We're going to start Chapter 11 now and go through chain drives. Alright, so we're going to talk a little bit about different chain drive types, what a sprocket is and different sprocket types. Talk a little bit about chain safety and install, and then kind of review what you're going to do in your lab. Alright, so if we take a look, alright, chains have been used for a very long time. They were used, as on bicycles back in the 1800s. So, advantage of chain drives. Okay, they're resistant to shock loads. So, very important. Why choose a chain drive, right? Resistant to shock loads. They can transmit high torques. They're economical. All right, they don't cost as much to make as something like a herringbone or things like that, or bevel gears or those sort of things. We're going to go through chain drive function and operation, the main functions. Where we use them a lot in material handling and power transmission. Okay, so there's three basic parts to the chain drive. There's the chain, the driver sprocket, and the driven sprocket. So some of it's going to be similar to what we did in gears. Okay, we have an output and an input gear, essentially, right? A driver and a driven, and we will relate the ratio based on the number of teeth as well. So having a good understanding of gears is already going to really help us with a good understanding of chain drives. Okay, the relative number of teeth between the driven sprocket and the driver sprocket, okay, just like in gears, determines the speed and the torque. So we're still using that same ratio for calculation. Okay, and the ratio is still the same. It's driven over driver, or I like to think of it as output over input when you go through that ratio. Okay, so this is nothing new as far as, conceptually with a ratio. We're just talking about a sprocket now, because we use a sprocket for a chain drive, not a gear drive. So if we take a look at the sprocket ratio, when we have a driven of 33 and a driver of 20, okay, we should have 33 over 20 when we do that. All right, let's talk about chordal action. Okay, the basic thing with chordal action is the chain does not ride completely along the pitch line because its link is a rigid bar that cannot bend to follow a circular path. The best example I can give you here is when we're talking about a train car, right? A train is like a box car that's going along, and even though the tracks bend, all right, the car's got to go that way. So we call that chordal action because the chain doesn't exactly bend like a belt or something like that fits on perfectly. Okay, so the chain link still remains straight as it moves around the pitch circle. Okay, the chordal action of the chain link causes some frictional losses between the sprocket and the chain. Okay, because we're engaging and disengaging on the teeth of the sprocket, so that's where that really happens. But we have rollers on the chain that help reduce that frictional loss, kind of like how we have like a bearing or something like that. Very similar, not exact, okay? But the rising and falling of the links cause a slight speed variation in the chain drive, all right, which causes a small amount of oscillation. And the oscillation depends on the number of teeth. If the number of teeth is greater than 25 on the sprocket, the oscillation is less than 1%, and we really disregard it. We don't even care about that oscillation. It's not enough for impacting our system. All right, the speed of the driven sprocket is determined by the sprocket ratio, not ration, but ratio there. This is because the rate at which the teeth of the driven sprocket engage a chain is the same as the rate at which the driver sprocket teeth disengage. Okay, so that's why we're able to do this, right? As we engage on one, we're disengaging on the other at the same time. Okay, so the different number of teeth constitute differential rotational speed as well as affecting the torque, just like gears. Okay, smaller sprockets are going to have a higher speed and less torque. Larger sprockets are going to have a slower speed and more torque. Okay, and when we're really talking about sprocket size, we're talking about teeth. Okay, so more teeth, less speed, more teeth, more torque. All right, speed, torque, still inverses of one another. Alright, so if we take a look here, these are some calculations we've already done. If we have the speed of the driven divided by, speed of the driver divided by speed of the driven is equal to the number of teeth on the driven divided by the number of teeth on the driver. So if you pause this and work through it, we've done a ton of these with the gear drives. I'm just going to throw the answer to you. The first one there, the speed of the driver should be 4,373 on the first example. And on the second example, the torque of the driver should be 161 inch-pounds. I'm not going to spend a lot of time going through the algebra there because that's pretty basic, and we did a whole bunch of those, like I said, during our gear drives. Okay. All right. So how does this really work with our chain drives? Okay. The chain pulls the driven sprocket. Okay, and the driver pulls the chain. Essentially, that's how that works. So power is transmitted through a single strand roller chain when the driver sprocket rotates its teeth, engaging the roller links, okay, and then it's going to pull that around. So, basically, think about you pedaling your bike, and you're changing sprockets in back. We've always talked about changing gears on your bike, but there really aren't any gears on your bike. They're all sprockets, all right? But the chain drive uses the engagement of the sprocket teeth in order to drive, all right? So it grips and pulls. Essentially, that's what you're doing. All right, so let's go through some basic types of chains here. You probably did not realize that there are multiple types of chains, and different ways of using each one, or where they're used in industry and why. So the first most common one is the roller chain. All right, we're going to get into detail in each one of these. I just kind of want to briefly touch on this slide. We have a rollerless chain, a silent chain, and a leaf chain. All right, so you can kind of take a look at the different aspects of it here, just in the picture, okay, and then we're going to go through it here. So this is a roller chain. It's the most common type of chain we use. It has rollers mounted on pins and bushings. All right, so you can kind of see there in the picture where the pins slide through. All right, and then it has a bushing there that allows the roller to freely rotate. So the whole point of that is to reduce friction on the chain drive, okay, and increase efficiency. So where you might use those, like just general machinery drives, conveyor system, robot drives, timing drives, all have roller chains with them. Okay, a rollerless chain, okay, they have nearly the same construction as roller chains, except for they don't have the rollers. So these are going to have higher friction. Okay, so since they have higher friction, we want to use them in lower speed drives. Okay, where the friction is actually going to cause less wear than normal. So always use these in low speed drives. We also use them in dirty applications. Okay, that's going to cause the roller chain bushings to wear out quickly if they were in the dirty application. So this is where rollerless chains are better, because the roller chain might get junk and stuff like that stuck underneath it as well, so that it can't spin. So where might we use these? Okay, hoisting chains or drives in small cranes or things along those lines. We have a silent chain here. So you can see how the silent chain is a bunch of flat links stacked upon one another, all right, with pins. They use an inverted tooth design. The whole point behind silent chains is to reduce the noise. Okay, that's a very important piece for them. In addition to being quieter, though, okay, they're more efficient, they last longer, and they can operate at higher speeds than roller chains. Okay, the downfall is obviously cost. It's going to cost a lot more to make a chain like this. Where we see them in industry, pumps, fans, other heavy machinery that need the use of silent chains. Okay, we have a leaf chain. Okay, multiple plates there. Okay, so really look, what's the difference between the silent chain and the leaf chain is the teeth. Okay, the silent chain is going to have those teeth that stick up, where the leaf chain does not. It just has a bunch of plates. Okay, there's no rollers. Okay, and they're not used in chain drive applications. Where we see them are wrenches, forklifts and other hoisting type devices because they're stronger. Okay, they have many plates. They're going to be much stronger than regular chains and things along those lines. All right, so other than those 4 types of chain, okay, and we know the roller chain is the most common type used in industry, there's 4 basic types of roller chains. There's a single strand, a multiple strand, a double pitch chain, and an offset chain. And here it's pretty obvious the pitch is what? The distance between pins. Okay, so you can see here the 4 different types of roller chains. And you know, if you look closely at the offset, you can see why they're called offset, where the plates and the pins kind of interact, and where the 2 plates, one kind of wedges behind the other as they link together. Okay, so the single strand, okay, most common one, is a single roll of chain rollers, okay, that make up the entire chain. Okay, they're used for most general purpose applications of low to medium type power transmissions. All right, and it's the one that you have on your bike at home. All right, it's multiple strand trains. Okay, so we can see it's really like 2 sets of roller chains side by side. For the most part, they're joined to create multiple rolls, and where we use them, all right, in application where we have heavier loads and higher speeds. Heavier loads and higher speeds than compared to the single strand chain. Okay, the double pitch chain, same construction as standard roller chain except for that the length of its length is twice that of a single pitch. We can obviously see that because of the gap that lies in there. So we normally use these when trying to save money on applications with low loads and speeds. Low loads, low speeds. So most of the time you might find them on like a conveyor drive or something like that. Not a heavy duty conveyor drive, but most of the time. Alright, so standard rollers contain 2 different kinds of links that mate with each other. This offset chain contains only 1 length, and you can kind of see how one sets behind the other as they link together. It doesn't require a linking chain in this case. Okay? In most chain aspects, that linking chain is a weakness. Since this offset chain doesn't have that weakness, alright, that's really its advantage is strength. Okay, it can be made with or without rollers, and it's normally made out of high-strength steel, and we use these in heavy load and low-speed applications. Kind of makes sense though, right? Heavy load means more torque. Alright, so our speed has to go down when we do these. Alright, you might take one of these apart in your labs, alright, but this is kind of how we would take these apart. You can see the rollers, the pin goes inside the bushing, the bushing goes inside the rollers when we're looking at the components of the roller chain here. So you can kind of break that down. That allows them to flex. Okay, so the different components, if we look up close, all right, so we can see those are the pins on the chain. Okay, and you'll see these when you actually do the chain drive lab as well, but those are the pins. Okay, these are called the pitch, right? The distance between the pins on each one. We have the rollers, okay, and then we have the roller link plates. So we call these the plates. All right, so main components here: pins, pitch, roller, and roller plates. And then lastly, we have the pin linking plates. So you can see the difference between those. Those sit on the outside of the chain. Okay, so remember, test question, right? Roller chain, that's the most common type. We have ANSI numbers. The first number is the pitch in 1/8 of an inch. The pitch will be in 1/8 of an inch. So, example, we have an ANSI 50 indicates a chain with a pitch of 5/8. The first number is a pitch of 5/8. Okay, the 5 is the first number, and remember the pitch is in 1/8 of an inch. Okay, and remember the pitch is the distance between the pins. Okay, so different types, right? The multiple strand, we use that to chain power capacity without increasing the pitch of the chain. So that's why we use a multiple strand roller chain. Heavy series roller chain, okay, they have thick side plates to withstand high shocking loads. Okay, and we'll see those because of the letter H on the side. So H will stand for heavy. Alright, we have a double pitch roller chain. The pitch is 2 times longer than in standard roller chains. Okay, we have a self-lubricating roller chain. Okay, so it has a small orifice in it that secretes small amounts of oil for that. We have an O-ring chain. Okay, so that seal the lubricant in the joints. Okay, that's what the O-ring does. We have different kinds of engineering chains. All right, so those are sidebar chains, pintle mill drag chains. Right, if you clean up a field or things like that, or those of you that have horses or something like that. Right, you make a nice arena to make the sand nice and flat and that sort of thing. Leaf chains, polymeric chains, or tabletop chains, all kinds of different chains that you can look at. All right, but let's get into what drives the chain is the sprocket. So we need to know some of the parts on a sprocket. Similar to a gear, okay, as we take a look at the sprocket, there's some common components here. So we have a bottom diameter. Notice that's at the bottom of the teeth, and the diameter is still the distance across the circle when we do that. Okay, the next part here, we have the outside diameter, so that's from the tip of one tooth to the tip of the other tooth that's on the sprocket. Okay, and this still similar to gears, right? We have the pitch diameter, all right, being halfway through that tooth from one side to the other. So if you can see, still very similar to gears, we have the face width of the tooth, okay, and we have the length through bore, right? So it's important that we know the bore is the size that's going to sit on the shaft, when we connect everything. So a lot of common nomenclature there. All right, the body plate and the hub. Okay, now the hub you can't see very well on the right-hand side. I have another picture coming up. You'll see the hub. All right, that's a little bit more support for the shaft. You can see the teeth, and you can see those different parts of the sprocket there. But we'll take a look so you can see the hub's underneath, the one on the left-hand side. And we'll see it in this view right here. Okay, so the one we were looking at on the previous slide where I said you can see the hub underneath, that was the second one over that you see here. But there's 4 types we're going to look at. We'll look at type A, that's a sprocket plate with no hubs. That's the diagram or the picture of the sprocket that's all the way on the left-hand side. So we're going to go left to right with our A, B, C, D. Okay, so all the way to the left, that's type A. All the way to the right is type D, and we're going to go in order. Okay, so type B, that's one hub projection. That's the most common. That's the one I showed you on the previous slide where the hub was sitting underneath. So you can kind of see the hub is the part that's coming off the plate of the sprocket. All right, that way our shaft has more to sit on, essentially. Okay, a type C has hubs on both sides, and then type D, we have a sprocket that has detachable bolts on the hubs, so we really lock those in tight. Okay, some exciting stuff here. We got sprocket part numbers, okay, and things like that. Most of this stuff you're going to go through, and wherever you work or design something, you're going to go through the specifications to the project, pull up your vendor data sheets, and take a look at things like that as you go through this. All right. But we're going to talk about the ANSI stuff here. Remember, ANSI is American National Standards Institutes. Okay, they maintain a standard for sprocket and chain design. So let's take a look at example 1. We have a sprocket that has a number 25A36-3/8. Then it is for the roller chain of an ANSI standard size of this. Okay, it's a 25 and an A style hub with 36 teeth and a bore diameter of 3/8. So you can kind of see how all those numbers correlate. Okay, the A style hub, which means there is no hub on each side, right? It's just a plate. It's got 36 teeth, and then the bore diameter is 3/8 for the shaft. Okay, we have a sprocket that has a number 50B21-7/8. What is its bore? So pause the video and answer these questions. Okay, and then you'll see if you're right as we go through it. Okay. Sorry, I didn't mean to click there. So if we take a look at this, okay, its bore is the 7/8. It's a type B, which means it has a hub on one side. Okay, and how many teeth does it have? It has 21 teeth. So you should be able to answer that fairly easily. Okay, so different special sprocket types. We got a split sprocket. That's to allow for installation of halves around the shaft. Okay, so it's just easier installation for that piece. We have a sectional rim sprocket. The rim is sectioned into 3 parts to allow for replacement without uninstalling the sprocket. Okay, so if something happens, we can fix it easier by only having to do one. We have a double pitch sprocket. That's obviously for the double pitch chain. Okay, we have a shear pin sprocket. The hub key is keyed to the shaft. The sprocket is free to rotate on the shaft when the shear pin that couples it to the hub is broken. Okay, so think about what we do with a pin as we slide it through, just when you're looking up doing your labs and stuff like that. Alright, most common drive ratio is 71. Okay, sprocket size as the number of teeth increases, variation of the chain speed resulting from the chordal action decreases. Remember, it had to be greater than 25 teeth, and we didn't even care about vibration and things like that. A good design practice for center distance is to use a center distance of about 50 to 80 pitches. Okay, so center of one board to center of the other. Now, you're going to do this in lab, so make sure that you pay attention. You don't want your chain too tight, okay, because it'll pull the sprocket off, or you don't want your chain too loose, because it'll fall off as well. Okay, so you don't want to have it too long or too short, also because of vibrations. Okay, sometimes we have an idler sprocket. Okay, it's a chain tightening device. This should have at least 3 teeth for engagement if we have an idler sprocket. Okay, if we just talk basic chain safety here, roller chains need to be inspected every 100 hours or first 100 hours. You're looking for nicks, dents, burrs, any abnormal wear. Rollers are already going bad, different things like that. Regular inspections should be made, in 3-week intervals. Does it really happen like this? Most likely not. All right, but it is important to go out there and check, make sure there's proper lubrication and those sort of things. And then, for more exciting stuff, you can read page 289 in your text. Okay, I'm not going to talk too much about maintenance because you can read through all this, but when you get to your place of work, they're going to tell you what they want you to do and how to maintain a chain. Okay, most likely if you're using a chain, it's in use. All right, so as long as you're keeping the correct distances, okay, and you're using the proper lubrication, you're monitoring it occasionally for misalignments, cracks, wear and tear, and that sort of thing, you're doing the right thing. Okay, so always look for those things. Make sure you're checking to see if the sprocket's not loose. And you'll kind of understand more of these when we do the lab in class, because if you misalign it, the whole sprocket's going to come off and that sort of thing. So it is important for us to align sprockets. Okay, we'll have 4 points of contact when we do that. I'll show you to make sure that we're going to use a straight edge to make sure the sprockets are mounted correctly and in line. You're going to inspect the sprockets, mount them, then you're going to mount the chain. Okay, align the chain sprockets, apply the proper tension, lubricate the chain, run the motor. All right, and then you're going to recheck the chain sag and chain motor. Okay, those are just general steps for install. You guys are going to do one of these labs in person. All right, on the trainer. Should be good. And then in class, we're always going to, it might be on your test, might just be at random, but I'm going to hand you a sprocket, and you should be able to give me all these different measurements for that sprocket. The bore diameter, the pitch, the number of teeth, the type of sprocket. Okay, and I might have you look up some different specifications for it. Alright, so make sure that you know how to use a dial caliper in this case. If not, I will make sure that I show you before we get to this part of the lab. Alright, well that's the end of this chapter. Everything you wanted to know about chain drives and sprockets and that sort of thing. Like usual, guys, if you have any questions, email me or ask me in class. Else, have a great day. I'll see you.